Number 2. To graph and solve problem solving using rational function. Number 3. To discuss the definitions of asymptotes. Rational function. A rational function is any function which can be defined by a rational fraction, an algebraic fraction, such that both the numerator and the denominators are polynomials, where f of x is equals to p of x as numerator divided by q of x as denominator. Definition of asymptotes. Number 1. The line is equals to A is a vertical asymptote. If the graph increases or decreases without bound, one or both sides of the line as x move in closer and closer to x is equals to A. Definition of asymptotes. The line is equals to B is a horizontal asymptote. If the graph approaches y is equals to B, as x increases or decreases without bound, note that it doesn't have to approach y is equals to B, as x both increases and decreases. It only needs to approach it on one side in order for it to be a horizontal asymptote. Process of graphing a rational function. Number 1. Find the intercept, if there are any. Remember that the y-intercept is given by x is equals to 0 and f function to 0. And we find the x-intercept by setting the numerator equal to 0 and 16. equal to 0 and solving. Number 3. Find the horizontal asymptote if it exists using the fact above. Number 4. The vertical asymptotes will divide the number line into regions. In each region, graph at least one point in each region. This point will tell us whether the graph will be above or below the horizontal asymptote. And if we need to, we should get several points to determine the general shape of the graph. Number 5. Sketch the graph. The following facts about the asymptotes. Number 1. The graph will have a vertical asymptote at x is equals to a. If the denominator is 0 at x is equals to a, and the numerator isn't 0 at x is equals to a. Number 2. If n is less than 2m, then the x-axis is the horizontal asymptote. Number 3. If n is equals to m, then the line y is equals to a times b is the horizontal asymptote. Number 4. If n is greater than m, there will be no horizontal asymptote. Figure of asymptotes. What asymptote can look like in a graph function? Y is the vertical asymptote. X is the horizontal asymptote. Slant asymptote or oblique asymptote. Okay guys, welcome to our topic, rational function, where f of x is equals to 1 over x is hyperbola. So all you have to do is to first make a graph of x and fx function, or function of f of x, which equal to y. So we have 0, 1, 2, 3, 4 as a positive, negative 1, negative 2, negative 3, negative 4. So all you have to do is to substitute the value of x in terms of f of x. And how do we do that? We know 0. So 1 divided by 0 is undefined. And then, so 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. And then 1 divided by 4 is 1/4. Am I right? So again, let's substitute the negative 1. So 1 divided by negative 1 is negative 1. 1 divided by negative 2 is negative 1/2. And then 1 divided by 3 is negative 1/3. And then 1 divided by negative 4 will be negative 1/4. So first, we need to graph the positive 1 as a vertical asymptote. Or, how do we find the vertical asymptote? Vertical asymptote is the y-axis. So this be considered as a vertical asymptote of y. So we have 1 and 1. Where do we put the 1 and 1? Here. And then 2 and 1/2. So this is the 2. Half of 1 is then. And then we have 3 is 1/3. And then 1 and then 4 and 1/4 will be here. So look for the other side of the point, which is the 1/2, 1/3, and 1/4. Then after that, we will graph. So we will graph in this one. Let's have the column 1. Placing the dot here. Okay, so this will be, take note guys. So if we will draw the graph, see to it that it continuously, that's why I draw means the infinite. It means to say it does not, or it does not touches the lines of 0. So here, and we will graph. So negative 1 and 1 will be here. So negative 2 and 1/2 will be here. And then 3 and 1/2, and then 1/4. So we will look for the other side. So on, so on, and so on. So we will. Okay, so it means to say this is the graph of hyperbola function, or the graph of rational function in the value of f of x is equal to 1 over x. So it means to say this is not touches the y is equals to 0 or x is equals to 0 because of this infinite, same as this one. Okay, so this will be the graph of rational function in a hyperbola. So this is the position. Take note position of this one. Okay, let's have another set of example of y is equals to x plus 2, 3x minus 6. So let's graph the rational function. First, we need to find the vertical asymptote. So our given y is equals to x plus 2 divided by 3x minus 6. The vertical asymptote first. So our vertical asymptote should be on this point. 3x minus 6 is equal to 0. Right? So 3x minus 6. Okay, we will transpose. So this will become 3x is equal to 6. So divided by 3, divided by 3. And then x is equal to 2. So we will draw an imaginary line for our vertical asymptote. So this will be our imaginary line. Okay, so this will be our vertical asymptote. And horizontal asymptote will be, if this is our denominator, will be 3. And this one will be the value of 1 automatically. This is 1/3. So where do we put the 1/3 here? Here. So we will draw an imaginary line. Horizontal and vertical. So we have already put the vertical and horizontal asymptote. So it means to say we will grab this one in order not to touch the vertical and horizontal asymptote. So we will replace 0 as negative 1/3. So negative 1/3 here, around here. And then 1 will be negative 1. 1. So where do we put the negative 1? The negative 1 here. Okay. And then 0. So 0, 1/3. Okay. So we have already our plotted point. And then after that, we will plot the point here. So we have already the curve 1. Curve. So we will continuously the other one will be 3. So if this is the 3, so around here 5/3. So we will put the up here 5/3. 5/3 means 1 something around here. And the other one 4. So we will go around 5/3 here. And the other one will be 1. So 4 is equal to 1. Our curve. So let's try to have the curve here. And we will grab here. Sorry. This one. Okay, so let's have the black one. So this will be our graph, and then continue with it. This will be the graph of x plus 2 divided by 3x minus 6. So, give the domain and the range. So the domain will be D. So, all the elements of x. So, it means to say all the elements of x, all the values of x. Not only x is equal to 2. Not only 2, all the value of x and the range are all the elements of y. So all the value of y, but not only y. Y is not only in 1. So this will be the answer for our domain. This will be the graph of x plus 2 divided by 3x minus 6. Okay, let's have another set of example of rational function. And our given f of x is equals to x squared minus 3x plus 2 divided by x squared minus 5x plus 6. So all you have to do is to factor out x squared minus 3x plus 2. So, what will be the factor of 3x or x squared minus 3x plus 2? We have the factor of x minus 1 multiplied by x minus 2, right? Because x times x squared. Negative 1 times negative 2 will be positive 2. And then if we will add negative 1x and negative 2x, the answer is negative 2x. And what will be the factor of x squared minus 5x plus 6? So we have x minus 2 and then x minus 3. So we cancel and cancel this one, and the remaining will be x minus 1 and then x minus 3. Am I right? So first, we need to find the vertical asymptote. So we will draw the vertical asymptote. Vertical asymptote is the VA. So the remaining guys will be x minus 3. So x minus 3 is equals to 0, and then our vertical asymptote will be 3. So again, let's graph for the x is equal to 3. So where do we place 3 here? And then put an imaginary line. Imaginary line, guys, ah. And then we know that our horizontal asymptote, suppose this is m is equal to n. So we have a already n is equal to n. So our numerical coefficient here is 1 and the other one is 1. So 1 divided by 1 is equal to 1. So y is equal to 1. So where is 1 here? So we have 1 here, right? This is our 1. So we will draw a horizontal asymptote. We will draw an imaginary horizontal asymptote. So this will be our. Okay, so we have already drawn the vertical asymptote and horizontal asymptote. So again, we will plot some points. So what are the combination of these numbers? So we'll start with 0, 1, 2, and 2.5. So if this is our start from the 0, so our combination will be 1/3. So we will have 1/3. And then 1 will be the 0. And then 2 will be the negative 1, and 2.5 will be negative 3. So this will be for the left. Take note, guys, this is for the left. And then, so 3.5, this will be for the right. Okay. So first, we need to graph 0 and 1/3 for the left. Where is the left? Here. So 0 and 1/3. Let's have a 0 and 1/3. So this is the plot of 0 and then 1/3. Okay, guys. So this would be the 1/3. 0 and 1/3. Take note, guys. First step. Look at my finger and the plot point in my pencil pen. And then 0 and 1. Where to plot 0 and 1? So 0 and 1. And then we have 2 and negative 1. 2 and negative 1 here. And then 2.5 to this 3. So 2.5. So there 2.5 and then 3 here. Right. Here. So we will graph. So we will graph here. So plot the point. Okay, so this will be the graph for the left. And how about to the right? How do we graph from to the right? So we have 3.5 and 5. So where do we place 3.5? Here, this is 3.5 to the 5. This will be the first dotted point. Followed by 4 and 3. 4 and 3 here. Okay. the other one will be 5 and 2. So we will have 5 here. We have 3 here. Sorry. We have 5 here. 3. We have 2. And then 1.67. And then 1.5. Okay. Guys, take note. So if you will plot the points to it, it will not touches the vertical asymptote and horizontal asymptote. So let's go to the right one. 3.5. I repeat, where is 3? This will be the 3. And then where do we put the 3.5 and 5? So around here. This one. 3.5 here. I'll take note 3.5 here. Okay. This one, alignment from 3. Half of in between of 3 and 4. Followed by 4 and 3. Where do we place the 4 and 3? Around here. So 5 and 2. Where do we put 5 and 2? Here. Here. So we have 6 and 1.67. So around here, 1.67. And then 7 and 1.5. So here. So let's follow the graph. Let's follow the graph here. So this will be x squared minus 3x plus 2 divided by x squared minus 5x plus 6. And then let's look for the domain. How do we interpret the domain? So the domain here is D. So element of x, not only x is equal to 2 and 3. And the range will be part elements of y, not only y, is equal to 1. So all the value of y are the elements, and the value for the range and for the domain, all the elements x. So not only, take note, not only m. So guys, this will be our rational function, x squared minus 3x plus 2 divided by x squared divided by 5x plus 6. So this is the our graph or our rational function. Okay, let's go for another set of examples. graph of rational function, which is the given f of x is equal to x squared minus 2x minus 3 divided by x minus 2. And then how do we solve for this one? First, look at the first degree, x squared minus 2x minus 3. And then we have to factor that. So what will be the factor of x squared minus 2x minus 3 will become x plus 1 times x minus 3. So divided by x minus 2. So respectively, if you will get the value of x plus 1, automatically this will become negative 1. So in case negative 1, and the other one will be positive 3. So it means to say our y-intercept will be 3 over 2. How? How do we come up 3 over 2? So f, if we will place function of 0, we have 0 squared minus 2 times 0 minus 3 divided by, and we will transpose, this will become 2. So 0 minus 2, and the answer is 3 halves. Right? So take note guys, this is m is greater than n. So exponent is 2 and the exponent is 1. So our asymptote will be none. Take note horizontal asymptote will be none. So HA will be none. Okay, because of m greater than n. So vertical asymptote, if we will transpose our vertical asymptote, so x minus 2, if we will transpose, x is equal to 2. And then, how do we graph x is equals to 2? So we will go here and then make a vertical line. Guys, a vertical line. So next will be, how about, so if there will be no horizontal asymptote, how do you identify that? And let's make divide this one. So let's have a space here. So let's go for the division, long division method. X squared minus 2x minus 3 divided by x minus 2. Okay, we will divide. So x squared divided by x will be x. And then this will become x squared. And then minus 2x. So the remainder will be negative 3. So our format, this means that f of x is x. So we will write the remainder here divided by x minus 2. So it means to say this is y is equals to x. We know that y is equals to x is a slant. Please note that slant asymptote. Okay, so y is equals to x. So how do we graph y is equals to x? So it means to say, this is, we will replace this one in the center, and we will dot, 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 dot. Take note, it is just like a, okay, so this will be our slant asymptote or oblique asymptote. So first, let's find out what will be our graph. So look at this one. So we have 0, 0, 1, negative 1, negative 2, and then the 2.5, maybe around here, take note. So 3, 4, 5, 6, so maybe on the other side. So in the right side, we will draw, take note, it will not touch the slant and vertical. Maybe we will curve something here, and we will curve something here. Okay, so how do we do that? If we will estimate this one and this one, imaginary, we will draw a graph. So first, we need to write here as a 4. So 4, we have 3 halves, or 1.5, we have 0, we have negative 1.25, we have negative 3.5, we have 0. Okay, for the left, we have 3, 0, 2.5, which is about y, 4, and then we have 5.25, right? So how will you do that in a graph? So first, where is 1 and 4? How do I identify 1 here? Let's go first to the right. So 1 and 4. Where is 1 and 4 here? Here. This will be 1. Take note. Let's go ahead. Let's change our marker pen in the black. This is 1 and 4. 1 and 4. 0 and 1.5. So where do we place 0 and 1.5? 0 or 1.5. So 0 about 1.5 here. And the other one will be negative 1 to 0. So here, no, these are the points. This one. And then negative 2 and 1.25. So this will be negative 2 and 1.25. So this will be 2 and then here. This one. So let's graph. So we will graph. Let's follow the dot line, the guide, and then we will see starting this one. So this will be on the right side. How about the left side of 3 and 0? Where do we place 3 and 0? We will place here. Take note that 3 and 0. How about 4 and 2.5? We have 4 and then 2.5. Something here. Half of 3 and 0. No, this will be that. How about 5 and 4? We have 5 and 4 here. And the other one will be 6 and 5.25. So around here. So this one, this one, this one. Okay. So we have this one. Take note, guys. This one, this one, this one. And the other one will be 2.5. Or let's have a the other one will be 3, 0. So we have 3, 0, and the other one will be 2.5. So we have the 2.5 here, and then 3.5. Where is 2.5? Somewhere here, and then 5. So let's follow the graph. Take note, guys. So we have this one. This one, this one, this one, this one, this one. And we will graph. So let's have a nice marker pen. And then follow. Okay, and the other one. So this will be actually this one. We just only highlight. So this will be the answer for our graph in x squared minus 2x minus 3. So guys, divided by x minus 2. So this will be the graph. Just follow only the graph. So if you know how to graph, and as much as possible use as a marker pen. So this will be our answer for the rational function. Okay, let's have a rational equation for our problem solving. So problem number 1. A can do a certain job in 3 hours, while the same job takes B 4 hours. How long will both of them working together? So, guys, let's have an X. B the number of hours. So both complete the work. Both complete the work. Okay, we have 1 over X will be amount of work by both 1 hour. And so let's proceed for the working equation. So what will be our equation? So take note that A can do 3 hours. So A, we have 1/3. And B, 4 hours. This will become 1/4. Right? So let's proceed for the equation. 1/3 plus 1/4 is equals to 1 over X. So let's get the LCD of 3 and 4, which is 12. 12 divided by 3 is 4 times 1. 12 divided by 4 is 3 times 1, and then 1 over X. So multiply. 4 times 1 will become 4. 3 times 1 will become 3 over 12. So 1 over X. So cross multiply. So this will become X. 4 plus 3. And then cross multiply. This will become 12. So 4X. Distribute. This will become 3X. 12. So 7X is equals to 12. This is not yet finished. So 7X is equals to 12 divided by 7 divided by 7. So 12 divided by 7. The answer is 1, 5, and 7. 5 over 7. So 1 times 7 is 7 plus 5 over 7. So this will be our final answer. 1, 5 divided by 7. So this will be our final answer, our rational